Implicit and Parametric Differentiation Part 2. If y equals 2t power 3 plus 7 and z equals t square minus 4, then the rate of change of y with respect to z equals. Solution. First we find dy dt, which equal, here we have y equals 2t power 3 plus 7, so dy dt equals 6t square plus 0, and dz dt equals 2t, as z equals t square minus 4. The rate of change of y with respect to z equals dy dz, which equal dy dt divide dz dt equals dy dt 6t square divide dz dt, which equal 2t. So the result equals 6 divided 2 is 3, and t square divided t equals t. So the answer is letter C. Next question, question number 12. If x equals 2t power 2 plus 3 and y equals square root of t power 3, then dy dt at t equals 1 equals, so first we put y in the exponential form, so y equals t power 3 over 2. The required here is to find the dy dx, so first we calculate dy dt. dy dt equals, here we have y equals t power 3 over 2, so the first derivative is 3 over 2 t power 3 over 2 minus 1, which equal 3 over 2 t power half, and dx dt equals 4t, as x equals 2t square plus 3, so the first derivative equals 4t, and dy dx equals dy dt divide dx dt according to chain rule, which equal 3 over 2 t power half divide 4t. Now substitute t equals 1, because the required here when t equals 1, so dy dx when t equals 1 equals 3 over 2 multiply 1 power half divide 4 multiply 1, so it is equal 3 over 2 divide 4, which equal 3 over 2 multiply 1 over 4, and the result equals 3 over 8. The result is C. Question number 13. The rate of change of sine x power 3 with respect to cosine x power 3. So let y equals sine x power 3 and z equals cosine x power 3. So the required here is to find dy dz. So the required here is to find dy dz. What is the result of this differentiation dy dz? First we find dy dx, which equal the derivative of sine is cosine x power 3 multiply the derivative of x power 3 is 3x square. So dy dx equals 3x square cosine x power 3 and z equals cosine x power 3. So dz dx equals the derivative of cosine is negative sine x power 3 multiply the derivative of x power 3 is 3x square, which equal negative 3x square sine x power 3. So dy dz equals dy dx divide dz dx, which equal, I'll put it as a numerator and the denominator, 3x square over cosine x power 3 over negative 3x square sine x power 3. So we can divide up and down by 3x square. So the result equals cosine x power 3 over sine x power 3, but it is negative cotan x power 3, and we choose letter A. Question number 14. A point x and y moves on a curve such that dx dt equals t square and dy dt equals 2t. Then the slope of the curve at t equals 1 equals 1 of this. The slope of the curve means the slope of the tangent at t equals 1. So the slope of the tangent equals dy dx. So from the given dy dx equals dy dt divide dx dt according to chain rule, which equal dy dt equals 2t equals dy dt equals 2t. Here is divide dx dt, which equal t square. So the result equals 2t divide t square equals 2 over t. When t equals 1, here substitute t equals 1, then dx dt, sorry, dy dx, it is the slope of the curve, which equals the slope of the tangent, equals 2 divide 1, which equal 2. And the answer is letter B. Next question. The slope of the tangent to the curve y equals t square plus 2t and x equals t square minus 2t. It is a parametric form for the curve, for the equation of the curve y equals t square plus 2t and x equals t square minus 2t. It is the equation of the curve. Here is the required is to find the slope of the tangent. The slope equals dy dx, which equal dy dx equals dy dt divide dx dt equals dy dt. Where is y? Here is we have y equals t square plus 2t. So the first derivative is 2t plus 2 divide dx dt, which equal 2t minus 2. Okay, at t equals 2, so substitute x equal to at t equals 2, then dy dx equals 2 multiply 2 plus 2, substituting t equals 2. So we have 6 divide 2 multiply 2 minus 2 equals 2. So the result equals 3, and the answer is letter D. Next question. Here, the tangent to the curve. What is the equation of the curve? We have x equals t square minus 1 and y equals t square minus t. Again, the tangent to the curve. This is the equation of the curve. It is a parametric equation. It's parallel to x-axis. When the tangent parallel to x-axis is parallel to x-axis, then the slope of the tangent, equals 0. What that mean? That mean dy dx equals 0. Okay. Here is the required here is to find the t when the tangent is parallel to x-axis at t equals, so what is the value of t? dx dt, dy dt, here dy dx equals, sorry, dy dx equals dy dt divide dx dt, which equal, what is the result of the first derivative of y with respect to t? It is 2t minus 1, as y equals t square minus 1 divide dx dt. We have x equals t square minus 1, so the first derivative is 2t. So it is equal 2t minus 1 divide 2t. Okay, and this ratio, this fraction equals 0 according to the given, because they said the tangent is parallel to x-axis. It means the first derivative equals 0. So put 2t minus 1 over 2t equals 0. It means make it as a cross multiplication. 0 is 0 over 1. Cross multiplication, 2t minus 1 multiply 1 equals 2t. So we have 2t minus 1 equals 2t multiply 0 equals 0, implies 2t equals 1, which means t equals half. 1 divided 2 equals half. and the result at letter C. Here is letter C. Question number 18. Let f of x equals 2x power 3 plus 1. F of x equals 2x power 3 plus 1, and h of x equals x square. Then f dash of h of 3 equals one of these values. First, I'll calculate h of 3, considering h of x equals x power 2. So h of 3 equals 3 power 2, which equal 9. Then f dash of x equals 6x plus 0, which equal 6x. We have here f of x equals 2x power 3 plus 1. The derivative of 2x power 3 is 6x square, actually 6x square. 6x square plus 0, which equal 6x square. Okay, now the required is to find f dash of h of 3, but h of 3 equals 9 here. H of 3 equals 9, so it is equal f dash of 9. Substituting in this in right hand side, so it will be 6 multiply 9 power 2. So we write 6 multiply 9 power 2, which equal 486. 486, and we choose letter C. Letter C. Next question. Here we have f of x equals 3x square minus 2. Then f circle f all dash of negative 1. So first we calculate f circle f of x. It is equal f of x. We have f of x equals 3x square minus 2. If you substitute x equals 5, so f of 5 equals 3 multiply 5 square minus 2. If you substitute x equals g, so f of g equals 3g square minus 2. Now we substitute x equals f of x, so the result equals 3 f of x all square minus 2. Okay, which equal 3 f of x. It is 3x square minus 2 all power 2 minus 2, which equal 3 multiply 3x square minus 2 all power 2 equals the first square, it is 9x power 4, minus first by second by 2, it is 12x square plus 4 all minus 2. Okay, now you can substitute x equals no, here we have f dash of x, we have f circle f of x equals this value. Now I'll get the first derivative, f circle f dash of x equals 3 multiply the derivative of this quantity. It will be 36 x power 3 minus 24x plus 0, minus 0. Now substituting x equals negative 1, what we get? We have f dash, f circle f dash of x equals 3 multiply 36 x power 3 when x equals negative 1. Let me write it again. Negative 1 according to the required. The required here is to find f circle f all dash of negative 1. So substituting x equals negative 1, negative 1 power 3 equals negative 1 multiply 36, it is negative 36 plus 24, which equal 3 multiply negative 36 plus 24 equals negative 12. Multiply by 3 equals negative 36. And the result will be in letter A here. A. Okay, and you write A. Question number 20. Which of the following curves has a tangent with a constant slope? Let us test each of these curves. We have A equals in A x equals sine t and y equals cosine t. So dx dt equals cosine t and dy dt equals negative sine t. So the slope equals dy dx. dy dx equals negative sine t over cosine t, which equal negative tan t. It is not constant. The required here is to find a constant slope. Okay, the slope equals dy dx, and dy dx equals negative tan t. It is not constant, it is variable. It depends on the value of t. And b, we want to find dy dx. dy dx equals dy dt, which equals 6 t over dx dt, which equal 2t, which equal 3. It is constant. So the solution will be in letter B here. Okay. In each of C and D, the first derivative, which equals the slope, dy dx, it will not be constant. Next question. We have f of x plus f dash of x equals, we write it, f of x plus f dash of x equals x power 3 plus 5x square plus x plus 2. Okay, where f of x is a polynomial function, then f of x equals, what is the value of f of x? F of x equals one of this. Let us try each one of this, and we deduce the sum of f of x and f dash of x. Starting from A, consider f of x equals x power 3 plus 2x square minus 3x. So f dash of x equals 3x square plus 4x minus 3. Now we will add f of x plus f dash of x. F of x plus f dash of x equals x power 3 plus 2x square plus 3x square equals 5x square minus 3x plus 4x equals positive x minus 3. It is not a solution because here the required f of x plus f dash of x equals x power 3 plus 5x square plus x plus 2, but here it is negative 3, not 2. So the polynomial at A, not f of x. So it is not a solution. Okay, let us try B. After you try B and C and D, you will get the solution at letter D. Let us try it. Consider f of x equals x power 3 plus 2x square minus 3x plus 5. So f dash of x equals 3x square plus 4x minus 3. Now f of x according to the required f of x plus f dash of x equals here f of x plus f dash of x equals x power 3 plus 2x square plus 3x square equals 5x square negative 3x plus 4x equals positive x. 5 minus 3 equals 2. And I think, yes, this is a solution. X power 3 plus 5x square plus x plus 2. So f of x, it is a polynomial in letter D. Question 22, f of, I write it, f of 2x plus 1 equals x dot h of 2x minus 5, and h of 1 equals 2, h dash of 1 equals 4, then f dash of 7 equals, what is the value of f dash of 7? First, I must simplify this function, substituting or making 2x plus 1 equals z. Then 2x equals z minus 1 implies x equals z minus 1 over 2. Now the left hand side f of 2x plus 1 will be f of z, because I considered that 2x plus 1 equals z. So f of 2x plus 1 will be f of z equals x. What is the value of x? It is z minus 1 over 2 dot h of 2x minus 5. It means to multiply z minus 1 over 2 minus 5. Okay, now I'll simplify this fraction. It will be z over 2 half z minus half z over 2, it is half z minus 1 over 2, it is half. Okay, dot h of divide 2, so we have z minus 1 minus 5, it will be z minus 6. Now we have f of z equals half z minus half dot h of z minus 6. Okay, now we wanted to make a derivative for this function to find f dash of z. Okay, f dash of z. Here I make a derivative with respect to z. Here I have two functions. Here is the first and here is the second. So the result equals derivative of the first will be half. It is the derivative with respect to z. Only half. Half minus derivative of half with respect to z equals 0. So there is the derivative of the first function, the first bracket, equals half. Multiply the second itself, h of z minus 6, plus the derivative. I write the first here, it will be half z minus half. Multiply the derivative of the second, the derivative of h of z minus 6, it will be h dash of z minus 6. Multiply the derivative of z minus 6 equals 1. Okay. Now the required is to find f dash of 7. So substituting z equals 7. We have f dash of 7 equals half multiply h of 7 minus 6 equals 1 plus half 6 half. Instead of z I write 7. So 7 multiply half, it will be 7 over 2 minus half dot h dash of 7 minus 6 equals 1. F dash of 7 equals half multiply h of 1. But from the given we have h of 1 equals 2. So I'll substitute h of 1 equals 2 plus 7 over 2 minus half equals 3. Multiply h dash of 1. What is the value of h dash of 1? Equals 4. H dash of 1 equals 4. So the result equals half multiply 2, it is 1 plus 12 equals 13. And the result at letter D. And I write D.